All right, everybody, welcome back to Binary Adventure. And I'm going to do a series here on Radare2, or aka Radare2. You're probably going to hear me call it two different things. I prefer to call it Radare2 now because, or just Radare, because it's simpler to say. Radare is actually 3 syllables, but I used to call it Radare, so I'm probably going to end up calling it Radare throughout. Anyway, so what I'm going to do is make short videos this time. I'm trying that out, and I'm just going to go over like one thing per video, and it's just going to be a little series. So this thing is known to be difficult to learn, and a lot of people just don't want to touch it because it's scary to them because it has a lot of sort of proprietary commands. And when I say proprietary, I mean that they're unique to Radare. They're, the thing's open source, so none of it's proprietary, but it has a lot of unique commands. And so in this video, I'm going to cover disassembly. Let's just look at some code statically. And we're going to do that for the next few videos, just cover static analysis. And then after that, we're going to cover dynamic with debugging. And then we're going to cover some of the other features. Radare has a ton of different features. It can do all kinds of stuff. In fact, now that I am using this instead of IDA Pro, I'm like, what the heck, considering the fact that this is free. And I mean, it's insane. It's probably the most powerful binary analysis framework on the internet, like out there right now. It's been under development for I think 11 or 12 years now, and it can do basically anything you could possibly think of for binary analysis. It can do it has like a calculator. It has converters. It can hash things, hash strings, encrypt strings, decrypt strings. It can do regular disassembly. It can do debugging. It can do kernel debugging. It can do remote debugging. It can do reverse debugging. Basically anything GDB could do. And I guess the debugger is actually lower level too, so it may be able to do some things GDB can't even do. And then on top of that, it can also do string searches. Basically like going through and looking for binary strings of all different types: Unicode, ASCII, wide, etc. It can do literally just about anything you could possibly think of. It can parse ELF headers, PE headers, so it can do things like what the Windows PE Studio would do. It's extendable. You can write plugins for it. You can run other programs within it, so you don't even have to leave Radare in order to do something like running Python scripts. It's pretty crazy. It can do all kinds of stuff. It's pretty amazing. So what we're going to do in this video now is I'm just going to get right to it. We're going to open up a binary. I have a couple binaries we're going to be working with in the series. For this one, I have a letter frequency program, which I wrote in C, which just basically outputs letter frequency. So let's say let's just do this. So I'm just going to run the program real quick so you can see what we're going to be looking at. Letter frequencies, and then let's just look at the file wonderful.c. So what it does is the file wonderful.c has capital I, and it basically gives you the letter frequencies for various letters inside of the file, and it could be any text file. So I'm going to clear that out, and now we're going to go ahead and get down to business. So we're going to do the name of the program is Radare2, but you can also shorten it to R2 when you're running it, is the alias for that. So I'm going to do R2 /letter frequencies, and that's going to open it up. And so now we have it open. So we have this thing here. What this is basically, I think they call it the pointer or the cursor. It's called the seek. Okay. And the reason why is because the command to change this is seek command, or S. And so what this does is that's like what we're currently at. So if you were to actually look at the disassembly, the line that we'd be on would be the line that this address is in the binary. Okay. So in order to do that, I'm going to hit Shift capital V, okay, and hit enter. And now it's like, whoa, what is all this? This is a hex editor, or this looks like a hex dump or something. So it turns out the way this works is that you have different views. And if you look up here at the top left corner, this is the current address that we're at. And as you can see, that's also going to be the address that's at the topmost line in any view, okay? So when I hit lowercase p, it switches over here to the disassembler view. And you can see we're still at that address. Now, if I hit lowercase p again, it switches to the debugging view. Now, we're not running the debugger in this video, but we're going to do it in a later video. But this is the view that you would be seeing if you're running the debugger, except I've actually, so by default, Radare only shows, I think, like 4 lines of the stack up here, usually. And I've actually extended that to show more lines of the stack. You can do that with a setting I'll explain in another video. Okay, but again, you can see that we're still at that same address. So now you hit lowercase p again, and it gives you a different type of like a heap hex dump view. And then you hit lowercase p again, and it gives you another view, like a strings view, right? You hit lowercase p again. This looks like it might be a diff view. Again, then you can see that all the bytes in the file are shown as ASCII hex text. So you could, if you wanted to copy and paste this into like an ASCII string or something like that, you could do that, or a byte string, you could do that in like Python or something, or in C. Okay, lowercase p again, and then you get this really cool colored visual mode that will basically assigns different colors to different byte types, so you can see things like, you know, it's almost like the entropy in the file and how the bytes are distributed. And so there is, I think, 1 or 2 other views, but I think that's good enough to get us started. So in order to go back to the other views, you just hold shift and you do uppercase P. So now you go back, and now we're back in our disassembly view, and then once again we're back at our hex view. So in order to change this, there's different ways of doing things in Radare. So everything I'm going to show you, there are other ways to do it, and I'm aware of that, but I'm just going to show you the ways I do, obviously, because I'm the one instructing the video. So you could press the up and down arrow keys or the J and K keys to go up and down. So you can see here I just went down. I pressed down 1 time. What it did is it changed now. Now the seek is at this address. You can see it updated. Now I'm going to go again. So whatever address is right here at this top line is the one that's currently selected by Radare to operate on. Okay, pretty simple actually. Hit lowercase p. Now you're in your disassembler view. Same thing here. See, as I go up and down, we have different addresses selected. So if we wanted to like do something like follow this call here, actually this is we can't follow this call statically because it's a relocation. So this is going to get resolved at runtime. But if it was a call we could follow statically, you would seek to here and then you hit enter and it would take you there. It would just be like double clicking on it in IDA Pro or another disassembler like Binary Ninja or something. Okay. So now the thing is that we haven't actually analyzed this file yet. And so in order to analyze the file, I mean, you want to analyze the file because right now we're not going to have anything in our symbols in our function list. So let's just kind of work through this like you would usually do if you're reverse engineering something. So the first thing you'd want to do probably is like see the list of functions or maybe the list of exports and imports and things like that. So in order to do that, you hit shift and colon. So you hit the colon key. It's like Vim, okay? So we're going to go ahead and do that. You can see down here at the bottom of the screen I have a prompt. In that prompt, in order to actually display the list of functions, we're going to type AFL, analyze function list. We get no output when we hit enter. The reason why is because we haven't analyzed the binary yet. So to analyze the binary, we're going to hit AAA, AAA, and it's going to tell you what it did right here. Analyze all flags starting with sim and entry, analyze length bytes of instructions for references, analyze function calls, and then it says you can do this other to perform an experimental deeper analysis. But AAA is good enough for most things, and it's good enough for this video, okay? So now that we've done that, let's go ahead and run AFL one more time. Now you can see here it has resolved all of these different functions that are in this binary. So now we have a main we could go to. Before we were just kind of in the boilerplate start code. So let's go ahead and close this out and let's see where we were. So you can see here that, well, I moved down a bit, but we're at the entry point of the program, which is not main, by the way. It's the boilerplate stuff. So in order to get to the main function, that's what we want to do now. What we're going to do is we're going to hit colon, and then we're going to hit S for seek, and then main. Okay, and what that's going to do, now you'll notice I hit enter, nothing happened. Why not? What's going on? So the reason why is because it hasn't actually updated the screen yet until we hit enter one more time to close out this prompt. Boom. See, now you can see that we are at the main function. So this is starting to look more like another disassembler, like IDA Pro. IDA Pro often will start you at main. Sometimes it will start you at start, but a lot of times it will jump to main for you. So that's how you do that in Radare. Okay. Now, we can just kind of go ahead and go through this. So now, as you probably know, if you've done any reverse engineering, the printf function is going to take us to a stub, which is going to jump elsewhere into an external library. But we can still see that stub. So just to show you, if you wanted to go down and follow a call, like I said before, you select it with seek. So we can see here that we have seeked to this call, and you hit enter. And now this is the stub code. You can see the jump here. This is the stub code for printf. Now, how do we go back? In IDA Pro, you hit escape. In Radare, you hit U. You hit U, it takes you right back to where we were. Okay, so now you're starting to be able to use this thing as an actual disassembler and do things and go places. So, and again, you can go and switch those different views. So let's say we want to see what this call code looks like in hex. We just hit Shift P, and we're at that code. That's how it looks in hex. Okay, and then hit lowercase p. We're back in disassembly view, and we're off to the races here. So I'm going to end the video here and tune into the next video to see how to get more information from this, how to follow cross references like you would do with X and IDA Pro, and we'll continue on how to see imports, exports, strings, things like that. Thanks for watching. Don't forget to subscribe and check out the next video.